All right, so in the last video, I talked about all of the various different rules that we need to know in order to do proofs. This is good. It's out of the way. If you needed that review, excellent. I'm glad you took it. If not, and you're just going to skip to this, that's fine as well too. If you are shaky at all on those though, go back to that video. Make sure you have that down because now we're going to start implementing those rules. And we have an example right here, right? This is a type of argument. This argument is composed of, let's see, 1, 2, 3, 4 different simple terms and 1, 2, 3, 4 premises. Now remember the way that arguments work is you use all of your premises, and as a result of those premises, the conclusion necessarily follows. Again, a valid argument is one in which you have all of your premises are true, and as a result of them being true, the conclusion is necessarily true as well. Meaning that if all of your arguments are true, there's no possible way without being self-contradictory that your conclusion would be false. We're going to use that idea to exploit our ability to determine whether or not this is a valid argument. So let's see how we do that. Well, this is the argument in and of itself. It says, I have a proposition. That same proposition entails one or both of these two propositions. The latter of those would entail another proposition, and we know that that other proposition is false. Therefore, we can conclude that the first of the two propositions in the second premise was true. It's a little hard to follow, I acknowledge. The book actually puts this into plain language, I want to say. Let me see if I can see where it does it then. Oh, no, I'm wrong. I thought that the book put one of these in an example plain English, where we could say something like, I don't know, it is Thanksgiving. If it is Thanksgiving, then there is either a bird on the table or a moose on the table. If there's a moose on the table, then there's a horse on the table. There's not a horse on the table, therefore there's a bird on the table, right? That's how we would put that into plain English. Now this one, you probably should be able to see it is valid, and I can know that it's valid because I know that this is true, and I know that if that's true, one of these must be true, and if one of those must be true, this is true, but I know that one's false. You can kind of see how it works. That's a good skill to practice. But what we want to do is we want to demonstrate with absolute certainty that this argument works. So remember, I said that if this works, if it's a valid argument, then the conclusion must necessarily follow from the true premises. So what I'm going to do is I'm just going to begin by assuming that each of my premises are true. When I put something in a number, that means that we're just taking it as true. So we're saying T is true. The relationship that's expressed in this compound equation is true. The relationship expressed here is true, and H is false. I'm taking all of that at face value. I'm going to ignore the conclusion, and that's why I put it in brackets. And instead, for my fifth line, I'm simply going to make an assumption. And that assumption, which I'm going to abbreviate ASM, is going to be not B. You might say, well, why did you do that? Every single time I start a proof in the way that I want you to be doing them, you begin by assuming that the conclusion of the argument is false. And what we're going to be checking is we're going to be seeing is it possible that the conclusion could be false? If it's impossible at pains of a contradiction, that means if I get something like A is true and and A is false. If I get two things like that, as a result of my assumption, I must know that there's no possible way for that assumption to ever work, and therefore it must be false, and therefore my conclusion necessarily follows as a result of that. When you are doing your proof, this is the best way to get the first immediate point. Most proofs will be out of 5 points. If I number them, thus demonstrating that I'm taking all the premises to be true, and if I bracket off the conclusion, write 5, assume not B, then I will automatically get a first point, which is pretty good because you didn't have to do much at this point. Now I'm starting a bracket that goes down here. This is going to signify that everything hereafter is true only if my assumption is also true. And so if I end up with a contradiction, I'm going to close my bracket off and say that assumption must have been wrong. And therefore the opposite of my assumption was right. So for now, I'll just kind of keep that bracket open. And I'll say, what can we do with all of this information? Remember, we have a bunch of rules for simplifying things. I'm going to try to ignore any simple premises that I have. And here, I'm going to use the term simple premise to refer not only to something like T, but also something that's negated. H, not H. Okay? So I'm just going to write, I didn't do this in class with you as much, but I'm going to do it because I think it's helpful practice. I'm going to write a little S next to the ones that are simple premises. And I'll even do that for my assumption right here. This is a simple premise, so I'm going to put S. This is a simple premise, so I'm going to put S. This is a simple premise, so I'm going to put S. And if it has an S over there, I'm going to more or less ignore it for the time being. I don't really need to do it to figure out what the next step is. Instead, I need to look at these two things that don't have anything next to them. And I'm going to see, is there anything that I can do to these? Now, if these propositions are either if I can apply a simplification rule to them, then I should immediately do that. Simplification rules are overpowered because you don't need any more information in order to get more content for our proof, right? If I told you P and Q are true, you can know with certainty that P is true and Q is true. So I can break those down into simple propositions. And once they're simple, I could write an S next to them and I could ignore them. Easy enough. But you'll notice I have T entails B or M, which is a fancy way of remembering that this we could treat as just a single idea. So this is just a complex way of expressing P entails Q. We have T entails this chunk of things. And so we're going to treat that chunk as its own term for now. And we're always going to look at the overarching operator. And this one would be an entailment sign. And so we can say, okay, so number 2, premise 2, is just an if statement. And we remember back, we think an if statement is an I rule. I need to know either that the antecedent, the first part of the if statement, is true, or the consequent, that is the whole last part, this whole B or M, is false. By the way, that would look like this. If we knew that B or M was false, it would look like not B or M. If I know that that's false, then I would know that T is false. So we are going to begin looking elsewhere in our information that we have. We don't have anything in 1, 2, 3, 4, 5, or anywhere else about B or M. So I'm not going to be able to do anything with that. But I do have information about T. And so if I add line 1 into line 2, I know that T is true, and so therefore I know by implication that B or M is also true. And so then I simply write, well, I'm using lines number 1 and 2 with the fancy if rule that we learned in the last video. Okay, let's continue down a little further. Line number 7, what else can we do? Oh, I forgot one step, and this is actually really helpful and pretty important. Once I've broken down a compound proposition, I've broken it down into various different parts, I'm going to put a nice little star next to it. That star is going to tell me I can ignore that proposition from here on out, because I already have the simplified information here and there. So now I look down my list and I say, okay, simple term, simple term, simple term. This is starred, so I'm going to ignore it. I have two things that I'm dealing with. I have M entails H, and I have B or M. Well, M entails H is another if rule, or it's an if statement, I should say. And so I'm going to need to know that M is true or that H is false in order to do anything. And I might look and say, I don't know anything about that. So I can't do anything with 3 yet. Let's skip it and let's come back down to number 6. 6 is an OR rule. Remember, the OR rule looked like this: P or Q. An OR is an entailment rule, an I rule, and so I'm going to have to know something is not true about one of those. And as a result of it not being true, I can know that the other one is true. So no P or Q. P is false, therefore Q is true. And I use the example if I say, if I'm about to write with the yellow marker or the orange marker, and I'm not about to write with the orange marker, I know I'm about to write with, I said the yellow marker, with the black marker. It's late. I'm doing this late. Okay, so there you go. I know that if one of these is false, I can affirm that the other one is true. Here, I'm going to look back up to all my lines. Do I know that either B or M is false? Nothing from here, nothing from here, nothing from here. Oh, I'm assuming that B is false. So I'm going to continue to operate under that assumption so long as I'm in the bracket. And I'm going to say if B is false, then M must, by implication, be true. And I used line 5, and I used line 6, and I used the OR rule. Excellent. Now, because I've broken this one down into its various different parts, I'm going to star that. At this point, 7 is a simple term as well. So let me do a little S there. I'm looking pretty good. The last thing that I have is that M entails H. I just learned that M was true. So I'm going to plug in my M right up here. And as a result, I'm going to get H. H must be true according to this assumption. So far, so good. So I plugged in 3 and 7 into that if rule. And as a result, I got H. Okay? Well, H is a simple term. And so at this point, and we've also broken this one down. Excellent. So it's looking pretty good. But herein lies the actual issue. You'll note that I have all of these simple propositions, but now if I compare the simple propositions, I'm going to see, oh look, T is true, H is false, B is false, M is true, H came up a second time. Up here, we said it was false, and down here, we said it was true. That is a contradiction, which tells me that if I make this assumption, I will end up contradicting what I ended up saying earlier. It doesn't matter when that contradiction occurs, so long as it occurs within an open bracket or somewhere on the problem that we're working through. And so I can close my bracket off and say this assumption was a bad assumption, and it must be false at pains of contradiction. And instead, the opposite of the assumption that we made, which is right here, must be true. Therefore, B must be true. And if you look, that was the original proposition that we were trying to prove in the first place. So you say B must be true. How did we figure that out? Well, I started an argument at 5. That argument continued up until line 8. The name of that argument, which is the one that I want you working with, is called the reductio ad absurdum argument. And then I found out that if I was to follow through with that argument, line 5 contradicts line 8. I'm just using an X there because it's kind of snazzy. I apologize. When I do these proofs, they tend to flow upwards eventually. That's the end of that. So I can demonstrate now what has been determined, QED, that this is a valid argument. And as a valid argument, I can say that given these 4 premises, the conclusion will necessarily follow. That's what we're doing when we make a formal proof. We're just simply applying the rules that we've learned in order to demonstrate that there will be a contradiction if a valid argument is assumed to be false, given the truth of its propositions, or its premises, pardon me. All right. In the next video, I want to show you how to come up with a refutation. That is, how to take an argument that has true propositions and we assume a false, or true premises and we assume a false conclusion, and it doesn't end up coming up with a contradiction. I want to show you what a refutation for that looks like, and then I will show you, finally, how to work with an argument that has multiple assumptions, and then I will just speed go through all the problems that we went through the other day. All right.